Hello? Okay, all of you just sit down. Settle down fast. All of you sit in your benches. Just don't roam inside the classroom. All of you settle down fast. Just don't discuss. Must stop talking. I'll go for one more problem here. All of you right? One more problem. Create a B tree. Stop talking, Amma. All of you just stop talking. Settle down fast. We need to create one more B tree. Create a B tree of order 5. Now this is only the last problem in insertion. Try to execute more number of problems based on your examples, okay? Create a B tree of order 5 by inserting values from 1 to 20. Creating a B tree of order 5 by inserting values from 1 to 20. Creating a B tree of which order? Order 5. Inserting a values from 1 to 20. Okay, 1 to 20. Now tell me, B tree here. Order, please tell me, order. 5. Now tell me what is the M value? M value 5. Now what is the key value here? M minus 1. First we need to calculate. Amma, last stop talking. Last stop talking. If possible, I'll give the deletion and the heap tree, but this is a complex one, okay? If you didn't practice, a big problem to solve this. This is a big complex problem. If you are unable to understand, by own that is not possible to solve the problem, okay? Try to listen carefully. Try to follow my steps. Start from 1 to the last. Start from 1 to the last step. Key M minus 1 equal to 4, okay? Now, how the node looks like here in this maximum number of elements? 1, 2, 3. So K1, K2, K3, K4. Maximum number of elements we can insert? 4. But previous example, order 3 na? Order 3 means M minus 1. How many number of elements, how many number of key values we can insert in your node? Maximum 2 third value we can solve by using your middle element. Okay? One level up like that. Okay? Now just see. We can insert how many elements now? 4 elements. Okay? How the node looks like? This is the node looks like. And now, first I need to insert which element? The values we can insert start from 1, 2, 20. 1 to 20. And draw the B tree for this. Draw the B tree for this. So first step, how the key looks like? This is your node. Yes, correct? This is your node. This is your node. And now, first, how many values we can insert from 1 to 20? First, you can insert 1 and 2. We can insert 2. So always start from 1 and 2 available to the right side. Always not available in sequence. Sometimes you will get 1, 9, 19, 17, 28, 32 like that. Okay. So not in the same 1 to 20 like this. But all the elements are available in which order? Sorted order. Okay. That is very important in B tree. Now, 1. So I want to insert 1 over and next 2. 2 available now here? Yes. Any problem? No. 2 you are inserted. Space available now for 2. 3 also available for space? Yes, 3 also very easy to insert. Space available for 3. Any doubt till now? No. 4 available. 4 space available for fourth element. Yes, also available. One more space available. 4. Till now, any doubt? No. You are inserted 4 elements in sequence. 1 compared and 2 compared with this 1 to right, 3 compared with this 1 to right, 2 to right, 3, and 4 compared with start from 1, 1 to right side 2, and 4 compared with 2 right side, compared with 3 right side. So 4 elements are inserted. Okay. Now I can fourth one inserted here. Now I want to insert which element? Next element 5. So possible here in this? Not possible. So just insert outside your node. Insert outside your node. Okay. Insert okay, fifth element outside of your node and find out the key value. Find out the key value means find out the root node for this. Same na, same process. Find the middle element 3. Which is the middle element? 3. And this one level up. This one moves one level up. Your identifies 3 belongs to the middle element and moves to one level up. Any doubt? No. Now you are identified 3. I want to draw like this. Okay. And 3 ki left hand entama? 3 ki left hand 1, 2. Okay. And 3 ki right enti? 3 ki right. It is 3 ki right. 3 ki left, 3 ki right. 4 and 5. Till now, any doubt? You are divided here. You are divided here. A node like this. 3 moves one level up. 3 belongs to the root node. And the below one belongs to 1, 2. And the down one belongs to 4, 5. 1, 2 available 3 to the left. 4, 5 available 3 to the right. Any doubt till now? No. And very important. You are inserted. You are inserted 5. Yes, correct? Now you are inserted 5. One more new B tree available in your hand. Okay, one more new B tree available in your hand. This is a new B tree. Yes, correct? The new B tree after inserting 5. Up to 4, no problem, but little bit big complex using 5. And now 6. How to insert? Once again starts from root node. 6 compulsory available and the space available in root node. Yes, but just don't insert in root node. Always new creation of an element in B tree inserted in leaf node, not in root node. If the space also available, just don't insert in root node. Always to the next level. So 6 available always to the right side of 3. Yes, correct? Right side of 3. Now right side of 3 means 4, 5. So in this node, 2 spaces available. So we are having the space for 6. Yes, we need to insert here like this. Now this is the new mode tree. One more new tree. All of you draw all the steps. I want to draw all the trees. Start from 1. 1. Second element, second tree. Third element, third tree. Fourth element, fourth tree. Okay. Final exam kuda ala draw cheyalama. Okay. Final exam lo direct ga final tree draw cheyedu. First element, second, third, fourth. 4 trees vachesnayi. Fifth, new tree available. Just specify. So we cannot insert fifth element in the given node. Why? Because always maximum number of keys available in your node only 4. That's the reason we are identifying the middle element. So third, 3 belongs to the middle element in between 1, 2, 3, 4, 5. So 3 we are pulling one level up and just the remaining 2 elements available in left side and remaining 2 more elements available to the right side and new B tree available in your hand. And each and every node available. Here 3 spaces, here 2 spaces, here 1 space. Okay. Now any problem in insertion of 6? No. Now I want to insert which element? 7. Insert 7. Once again, start from 3. Just don't insert here in root node. Just don't insert in root node. Why? Because in B tree, according to the B tree rules and regulation, always insert a new element in a next level leaf node. So 7 compared with the 3 available in right side. And now 4, 5, 6. Any space available to insert 7 here in this? Any space? Yes, very easy to insert. Very easy to insert. Very easy to insert. Now, over. One more tree. One more tree. This is one more tree. This is one more tree. One more new tree available in your hand. 4, 5, 6, 7 inserted. 4, 5, 6, 7 inserted. Till now, any doubt? Till now, any doubt? Now I want to insert 8. Now, in root node, spaces are available now. In root node, spaces are available. We can insert 8 in root node. No, always in B tree we can insert a new node in the next level in the leaf node only if you're having any space. Now, 8 compared with the 3 available only to the right side. Yes, we are identified one node available in this 4, 5, 6, 7. But here we are not having any space for 8. Here we are not having any space for 8. Yes, now we are not having any space for 8. So how to draw this one? How to draw? So we are identifies the middle element in this. We are identifies the middle element in which one middle element? 6. 6 moves one level up. 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 And 6 left side 4, 5. 6 right side 7, 8. 6 moves one level up. ఎక్కడికి వెళ్తుందమ్మా అది? దేని దగ్గరికి వెళ్తుంది? దేని దగ్గరికి వెళ్తుంది? 3 పక్కకి వెళ్తుంది. ఎస్ 3 పక్కకి వెళ్తుంది. సో ఇక్కడ 6 వచ్చేస్తుంది. నౌ టెల్ మీ Now tell me. Six moves to one level up. 1 to ఎక్కడ ఉంటుందమ్మా? 1 2 ఇంకా remaining space also available. Okay, remaining space also available. Here I'm not inserting remaining spaces. Next tell me 6 కి left ఏంటి? 6 కి left ఏంటమ్మా? 4 5. Remaining spaces also available. Here I'm not drawing. 2 more spaces available. And 6 కి right ఏంటమ్మా? 6 కి right ఏంటి? And remaining 2 more spaces also available. Okay, remaining 2 more spaces also available. Here I'm not drawing. That's it. Okay, and now any doubt till now? This is the new tree after inserting 8. This is the new tree after inserting 8. This is the new tree after inserting 8. Any doubt till now? Now I want to insert 9. So try to insert 9 in this root node. That is not possible. Why? Because always insert a new node in the next level. Okay. So 6 to the right. 6 to the right and 7, 8. Possible available now. So 2 more spaces available in this. 2 more spaces available in this. 7, 8, 9 in this. Okay. 7, 8, 9 and 10 also. 10 also inserted in this. 2 trees draw cheyali. 9 ku oka tree, 10 ku oka tree. Skip cheyadu. No more skips. Till now any doubt? Order of 5 this one. Order of 5 means total number of elements available in your node, that is maximum 4. If you reaches, if you exceed, if you identifies overload on that node, so try to identify the middle element and pull that middle element one level up. Try to identify the middle element one level up and try to identify the left side values and right side values. Still have any doubt? No. Next 10 out available. Next I want to insert 11. 11. 11. So 6 to the right. Yes, 6 to the right. Yes, correct. 6 to the right. 7, 8, 9, 10. And then next 11. Now once again a big complex. No space available in your node. Yes, correct? No space available in your node. Now tell me how to insert. How to insert 11? What is the new tree for this? Tell me the new tree for this. I think everyone knows. Identify the middle element. Pull this one level up and try to identify this is equal to left side element and this is equal to right side element for 9. Yes, correct? 9 to the left side 7, 8. 9 to the right side 10, 11. Okay? టీ డ్రా చేద్దాం. ఇక్కడ 9 వస్తుంది, ఇక్కడ 9 వస్తుంది. అంతే కదమ్మా? వన్ లెవెల్ అప్ అండ్ మీరే చెప్పండి అమ్మా. వాట్ ఈస్ ద లెఫ్ట్ ఎలిమెంట్స్ అండ్ రైట్ సైడ్ ఎలిమెంట్స్? ఐ డోంట్ నో. టెల్ మీ. ఇక్కడ ఏంటమ్మా? 1 2 ఏంటి కదా? లెఫ్ట్ సైడ్ ఏంటి? 1 2 ఇంకేంటి? 3కి రైట్. మీరు చెప్పండి, ఉన్న ట్రీ చెప్పండి. 3కి రైట్ ఏంటి? 4 5. ఎస్ కరెక్టా? ఇక్కడ 6కి ఏంటి? 7 8. 6కి రైటా? ఎస్, మీరే చెప్పాలి. 7 8. నెక్స్ట్ 9కి లెఫ్ట్. అది 9కి రైట్ ఏంటి? 9కి రైట్ 10 11. 10 11. ఓకే, 9కి రైట్. 9కి లెఫ్ట్ 7 8. 9కి రైట్ ఏంటమ్మా? 10 11. You divided na. 9 moves one level up and divided 7 8 to the left side of 9. 10 11 right side of 9. Left side 7 8, right side 10 11. Any doubt? 9 moves to one level up. 9 moves one level up and you are divided 7 8 to the left side of 9. 10 11 to the right side of 9. Yes, correct? Till now, no doubt. Now, I want to insert 12. Yes, here 12. We cannot insert 12 in your root node. Okay, we can't insert 12 in your root node. Why? Because according to the rules and regulations of your B tree, always we can insert a new element in the next level after root node. Root node తర్వాత ఉన్న లీఫ్ లోనే ఐడెంటిఫై చేయాలి. Now after 9 11 available, after 9 we are having 12. So 12 compared with 10 right side, 11 compared with 12 right side. Yes, space available, space available, space available. Okay, and 13 space also available. Yes, correct? 13 space also available. 4 elements now. 13 and 12, no problem. 2 elements are already inserted. Till now, any doubt? Listen carefully. Big complex one, this one, B tree. Like AVL tree, like BS tree, this is not the simple one. BSC just we are calculating balance factor. Okay, -1, 0 and 1. But here we need to identify the key value, order and levels of each and every children. If you exceed that, finally, if you overload on that particular node, identify the middle element. Always select the middle element one level up, identify the left side element and right side element. That's it. And next, we need to insert which element in the next level? 14. 14 available always CL to the right and need to insert like this. But 14 space available in this node? No space available for 14 in this node. Why? Because already 4 elements, 4 key values you already inserted. No space for 14. Now tell me. So identify the middle element. 12 belongs to the up and left side for 12, right side for 12. Tell me left side for 12. 10 11. 12 here. 10 11 and right side for 12. 13 and 14. Okay, you are divided 10, 11 to the left side of 12. 12 moves one level up, and 13, 14, 13, 14. Now, any doubt? Now, 15 I want to insert. Always all the elements in sorted order now. Always all the elements in sorted order. 15. Yes, we can insert here. We can insert here 15. And also 16. No problem. You are inserted 15 and 16 in your spaces. దీంట్లో కూడా 2 స్పేసెస్ ఉన్నాయమ్మా, దీంట్లో కూడా 2 స్పేసెస్ ఉన్నాయి. బట్ ఉంటే అవసరం ఉంటే యూజ్ చేసుకోండి, బట్ అవసరం లేదు. మనం స్పేస్ ఉంది ఎక్స్ట్రా. 13, 14, 15, 16. Now we can insert 17. Now I want to insert 17. Now I want to insert 17. 17 put here. 17 put here. And 13, 14. And you identify the middle element 15. This moves one level up. And 15 to the left, 13, 14, 15 to the right, 16 and 17. But no space available here at root node. Your mode here 15. Your mode here 15. 15 more to the root node side. Yes, correct? 15 more to the root node side. But no space available. Already space completed here. No space. Overload identified after moving one level up. After moving one level up 15 to the root node side. Now 3, 6, 9, 12. 4 elements are already identified. And no space for 15. No space for 15. But execute the same process. Execute the same process. Here 5 elements. Identify the middle element. One level up. And these 2 elements left side. These 2 elements right side. Now draw the new B tree. Now draw the new B tree. In that B tree, what is the root node? What is the root node? Speak loudly. 9 belongs to the root node. 9 belongs to the root node. Try to draw the new B tree for this in 3 levels. Now here I am drawing 9. 1, 2, 3 also available. And 9 కి left side ఏంటమ్మా? 9 కి left side go. 9 కి left side 3 and 6. 3 and 6. 3 కి left ఏంటి? 3 కి left ఏంటి? 1 and 2. 3 కి right ఏంటి? 4 and 5. 3 కి right 4 and 5. Now 9 కి left 3, 6 అయిపోయింది. 9 కి right ఏంటమ్మా? 9 కి right ఏంటి? 12 and 15. 9 కి right 12 and 15. 9 కి right 12 and 15. 9 కి right 12 and 15. Tell me where we can insert 7 and 8. Right side of 6. Always to the left side of 9 na. Always left side of 9. So right side of 6. 7 and 8. 10 and 11. Left side of 12. Left side of 12. Left side of 12. మళ్ళీ నీట్గా డ్రా చేద్దాం. లెఫ్ట్ సైడ్ ఆఫ్ 12 నా. వాట్ దట్ లెఫ్ట్ సైడ్ ఆఫ్ 12? 10 and 11. రైట్ సైడ్ ఆఫ్ 12 ఏంటమ్మా? రైట్ సైడ్ ఆఫ్ 12 ఏంటి? 15 moved. 15. 7 and 8 over to the 6. And 10 and 11 available to the left side of 12. And right side of 12? 13 and 14. 13 and 14. 13 and 14. 15 బయటకు వెళ్ళిపోయింది అమ్మ. 15కి రైట్ ఏంటి? 16, 17 అండ్ 18, 19 కూడా డ్రా చేయొచ్చు. Can I draw? 9 root node, 9 to the left 3 6, 3 ki left 1 2, 3 ki right 4 5, 6 ki right 7 8, 12 ki left 10 11, 12 ki right 13 14, 12 ki right 13 14, 15 ki left ఏంటమ్మా? 15 ki left 13 14, 15 ki right 16 17 and 18 and 19. ఎక్కడ ఇన్సర్ట్ అవుతుంది? So 20 here, we can draw the new tree for this. And where we can insert 20? You are identified 16 17 belongs to the left side and 19 20 belongs to the right side, and you are identified 18 belongs to one level up, and this one belongs to left, this one belongs to right. And tell me, what is the root node? What is the root node? 9. And 9 ki left 3 6, 9 ki 3 6 ki ikkada okati undi, 1 2 and 3 4 5 and 6 7 8 and 9 ki right 12 15 and 12 ki left side 10 and 11 and 12 right 13 and 14 and 15 right side. ఇక్కడ ఒక ఎలిమెంట్ ఉంది కదమ్మా. Now which element moves up? 18 moves up. So 18 కి లెఫ్ట్ సైడ్ ఏంటి అమ్మా? 18 కి లెఫ్ట్ సైడ్ ఏంటి? This one. 18 కి లెఫ్ట్ సైడ్ 16 and 17. 18 కి రైట్ సైడ్ 19 and 20. This is the new B tree. This is a new B tree. నీట్గా డ్రా చేస్తాను చూడండి ఇప్పుడు. First, you are identified root node 9 having 3 spaces. Three, 6, next year 1 and 2, next year 4 and 5, next year 7 and 8, 12, 15, 18 and 12 left 10 and 11, 12 right 13 and 14, 15 left అయిపోయింది. 15 రైట్ ఏంటమ్మా? 16 and 17, 18 లెఫ్ట్ అయిపోయింది అండ్ 18 రైట్ ఏంటి? 19 and 20. If you are having 21 in your hand, where we can insert 21? Where we can insert 21? First, we need to verify here in root node, space available, but go to the next level. 20 available to the right side, so 21 available to the right side of 12, right side of 15, right side of 18, and right side of. In which node? Tell me. 20 పక్కన కదా. So compulsory we need to insert into the next level. Just don't insert. And always in root node. To the next level. Move to the next level. Move to the next level only. Okay. Move to the next level. So here two spaces, two spaces, two spaces in the last two spaces. Always you will get the new next element only, not to the previous element in B tree. Okay, మధ్యలో ఇష్టం ఉన్న ఎలిమెంట్ రాదు. కానీ ఏవిఎల్లో వచ్చింది కదా, ఏవిఎల్లో బిఎస్సిలో వచ్చింది కదా మా ఇష్టం ఉన్న ఎలిమెంట్స్, ఇలా బి ట్రీలో రాదు. ఇన్ ఎవ్రీ ఎలిమెంట్ ఇన్ బి ట్రీ ఆల్ అవైలబుల్ ఇన్ సార్టెడ్ ఆర్డర్. So all elements are available in B tree. Those are in sorted order. All the elements in B tree, those are in sorted order. Only three rules. First, identify order M and identify the key element. Try to identify the node. How to accept the number of elements in your node. Maximum number of elements we can accept, identify, and the key value. So after identifying the key value, we need to identify all the new elements are inserted into the next level, not into the root node. And if you are inserted a new element into the next level, find out the new elements in all the levels. Now create a B tree. Create a B tree from A to S. Order 3. Create a B tree from A to S. Capital A to S. Order, you want 3 or 5? You want 5? Yes. Your favorite number 5. So take 5. Order 5. Order 5. M value 5. Create a B tree from A to S. A, capital A to S. S for Srikanna. So stop there. A to S. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S. I think everyone knows all these letters in sequential order. First, create A, B, C, D, then E. Stop there. Okay? At E, stop there. Identify the middle element, then go for up to the last. So this is exercise for you. Make it fast. Try to execute. Create a B tree. Now, any doubt in order 5 or order 3? No, na? So always in order 3, maximum number of elements are inserted only 2. Third element, identify the middle element. Fifth na, identify the middle element. Seventh na, identify the middle element. Third belongs to the middle element in order 5. Fourth one belongs to the middle element in order 7. Okay? So very easy. If you practice, very easy. So you will get maximum up to order 5 only. Okay? Order 5. You didn't get order 7. Maximum order 3 or order 5 only. Okay? B3 లో order 5 or order 3 ఇస్తారమ్మా, order 7 ఏమి ఇవ్వడు, అంత కాంప్లెక్స్ ఏమి ఇవ్వడు. So try to draw a B tree through using M value 5, that is order 5. Start from A to S. Must stop talking. Try to practice by yourself. Yes. S available in which node? Right side of? Yes, right side of. Yes. Space available, no problem. Space available. Must stop talking. Discuss within your bench. Discuss within your bench. Yes, see here. Constructing a B tree. If you exceed order, promote middle and split like this. Promote middle and split like this. Just see here. I given the graphics on this. Just see here. Okay. 1, 2, 8, 12, 15. You need to insert 25. Space not available now. Space not available. Okay. So you are identifying which element belongs to middle element. 8 belongs to the middle element. Is 8 moves one level up. 8 moves one level up and divided 1, 2 to the left side of 8. 12, 25 right side of 8. Okay. 1, 2, 8, 12. I want to insert 25. ఇలా ఇస్తారు 1, 2, 3, 4 అలా ఇవ్వడు 25 I want to insert. But 25 is it possible to insert? No. Like this. Exceed order, promote middle element and split. Promote middle element and split. 28. Where we can insert 28? Where we can insert 28? Where we can insert 28? 28. Here na. Then which element I want to insert? Adding. Okay. తర్వాత ఇస్తాను ఇంత కాంప్లెక్స్ మీకు వద్దు this advanced B tree without sorted order. Only one condition in this B tree. Based on the key value, based on the available key value in the last, identify the middle element. That middle element, if you exceed, if you identify the overload on your node, if you identify the overload on your node, identify the middle element, and that middle element moves one level up, split the left side two elements in order 5. Those two elements available to the left side of your middle element, and the right next two elements available to the right side of middle element. Okay. You are splitting. Can I insert once again? A, B, C, and D. Any problem till now? Till now any problem? Up to D? M equal to kitna? 5. And key value? That is equal to M minus 1 equals to 4. and that is equals to maximum number of elements 1, 2, 3, K1, K2, K3 and K4. Okay, K1, K2, K3 and K4. And next tell me E. A, B, C, D, E. A, B, C, D, E. Identify the middle element. Tell me the middle element. This middle element one level up and left side and right side. Tell me the new tree. C and C to the left. C to the left. A and B. C to the right. D and E. Till now any doubt? D and E. I think you already completed, huh? Super. Practice by yourself using many examples by own. Okay, practice by your practice by own, practice by yourself by own using many examples. Finally, no confusion. Try to find out, try to construct B tree using order 3, order 5 enough. If possible, if you already practiced, try to construct a B tree using order 7. Okay. Next, A, B, C, D, E. Then F and G. Yes, correct now? Till now, any doubt? No. H, a big problem. Identify this one and one level up. One level up. One level up. So we need to draw here like this. No confusion. C, one level up. Tell me. C, one level up. F. C की left hand अम्मा. C की left A, B. C की right D, E. And you are identified F belongs to the one level up. And next tell me F को right hand अम्मा. Till now any doubt? Till now any doubt? Any confusion? No. Two more spaces available in this. Two more spaces available in this. ఇది ఎఫ్ కు రైట్. ఎఫ్ కు రైట్ ఎంత అమ్మా? ఎఫ్ కు రైట్. ఎఫ్ కు లెఫ్ట్ డిఈ, ఎఫ్ కు రైట్ జిహెచ్. రైట్ రైట్. నెక్స్ట్ టెల్ మీ ఐ. EFGH, I and J. EFGH, I and J. Up to I, J, no problem. Up to I, J, no problem. EFGH, I, J, K. K. Once again, big problem now. When you are inserting K here, big problem. Identify the middle element. One level up. One level up. And draw the new binary search. Sorry. Draw the new B tree for this. One level up. One level up. Tell me the C, F, I and empty space. Yes, correct? And C ki left hand amma. C ki left AB. C ki right DE. And F ki right GH. You are divided now. I ki right and I ki left idi. I ki right. I ki right hand amma. J and K. The new tree. The new tree. This is the new tree. Till now any doubt? J, K, L, M. Up to M any problem? Up to M any problem? No. And now if you want to insert N, once again a very big problem. Once again a very big problem. L moves to up. L కి లెఫ్ట్ ఏంటమ్మా? J కి ఆల్రెడీ ఉంది కదా L కి లెఫ్ట్. L కి రైట్ ఏంటి? MN. L కి లెఫ్ట్ ఏంటమ్మా? L కి లెఫ్ట్ J K. L కి రైట్ M N O P. Remaining 3 elements are available here. Remaining 3 more elements to insert. Remaining 3 more elements to insert. I want to insert M N O P Q. Q available here, but we can't insert Q. We can't insert Q. We can't insert Q. We can't insert Q. And now tell me, identify. O belongs to one level up and O available here. O available na? Ante kada amma? O available one level up. O ku left side MN. O ku left side MN. O ku right side PQ. But here space available at root node. Space available at root node not available. Same process here, you are identified the middle element and you are pulling I belongs to the root node. I belongs to the root node and rest of the 2 elements belongs to left side, right side belongs to L and O. Pull the middle element, I belongs to the root node and CF belongs to the left side of I, LO belongs to the right side of I. Any doubt? Now tell me the root node. Tell me the new root node here. I belongs to the root node. I belongs to the root node. I belongs to the root node. And I ki left entama? I ki left C and F. I ki right enti? L and O. L and O. So C ki left enti? A, B. C ki right enti? D and E. And F ku right enti? F ku right G and H. And tell me here, I evarna I ki left side అయిపోయింది కదా, I ki right side ఏంటిగా LO అయిపోయింది. L కి left side ఏంటి? JK. L కి left side J and K. L కి right side ఏంటి? L కి right side ఏంటి? M and N. And next O కు right side. O కు right side. P, Q, R, S. This is the final B tree. Yes, this is your B tree. This is a B tree. This is the final B tree. The final B tree. Any confusion in B tree construction? A little bit complex, but try to execute by using your own problems. Then no confusion. Using order 3 sometimes, using order 5 sometimes. Okay? If you practice by yourself by own, very easy to understand. Try to practice by yourself and just verify. If you're having any confusion, try to verify the previous pages. So then those confusion, those mistakes, those wrong things are corrected in the next level, and you identify the new things or the updated one up to the last in your brain, in your intelligence. Okay. Now once again we are having many spaces in this root node. Okay. Up, and so on. We need to identify bit rate deletion. Yes. Right. Bit tree deletion. Deletion of a bit tree. Deletion of a key element from the given B tree. Deletion of a key element from the given B tree. Now just draw here one B tree I want to draw. Stop talking. I'll go for deletion first. Before that, I need to draw one ordered 3 BST from A1 to A10. A10. You already drawn na? 1 to 10 you already drawn na? So already చాలాసార్లు వచ్చిందమ్మా. A1 to A10, draw a binary, draw a B tree, okay, draw a B tree, order 3 using A1 to A10. 1 to 10 already completed. కన్ఫ్యూజ్ కావద్దు, అలాంటి క్వశ్చన్స్ వస్తాయి. 1 to 10 already డ్రా చేశారు కదమ్మా. A1 to A10 also same. Yes, correct? A1 to A10 also correct. Now I will give one more new insertion problem. Small B tree, 1 2 3 4 5 6 7 8 elements available. Order 3 with these elements. Order 3 with these elements: A1, B1, A1, B1, B6, C2, C22, D5, D6, D32, D32, D32. I'll ask a few members to draw this one. Order 3. Yes, just stand in your place. Yes, stand in your place. First, I want to insert A1. Yes, correct? I want to insert A1. Tell me the order. Order already given. M equal to. Order means M. M equal to which number I given? 3. M equal to 3. M equal to 3. M equal to 3. So M equal to 3 you are given. And tell me key value 2. Tell me how the node looks like here. K1 and K2. Yes, K1 and K2. K1 and K2. Try to draw, make it fast. Try to draw, make it fast. Draw cheyanam. Try to draw, make it fast. First, we need to draw these 3 elements in box. Before constructing B tree, try to draw these 3 elements in box. M equal to, key equal to, K1 and K2. Now tell me here. Order 3 means only 2 elements maximum it can accept in your node. Only maximum 2 elements it can accept. Try to practice by yourself. You're already exhausted. In deletion, I think, little bit complex to execute. That's the reason here I'm giving few more problems to understand the creation of this B tree, then go for deletion in the next level. I'm thinking, any confusion in creation of a B tree? Based on the order, based on the key value only. Always try to move one level up to the root node. But just don't insert a new element in root node directly. Just don't create a new element. Just don't insert a new element directly in your root node. Yes, first bench, last. First bench. Yes. Who's that? పేరు చెప్పండి అతను ఎవరు ఈ ఫస్ట్ బెంచ్ ఈ ముగ్గురు ఉన్నారుగా లాస్ట్ బ్లాక్ షర్ట్ అది పడుకున్నాడా పాపం జస్ట్ స్టాండ్ ఇన్ యువర్ ప్లేస్ ఎస్ stand in your place. Yes, first create a node. First we can insert A1 and B1 directly, cut like this. Okay, then go for C1, then go for C1 ఉందా C1 అంటే ఓ అంటాను లేదు ఏముంది B6 ఉంది B6 available. Always next element belongs to the new element belongs to the right side of that particular element. Available in sorted order. Yes, correct? Already given sorted order. Next B6. B6 here. B6 here. And identify this left side and right side. Left side and right side. Tell me the root node. New binary tree, also called B tree, updated generalized version of binary tree. Okay, advanced version of binary tree after AVL. So here B1 belongs to root node and one more B1 ki left hand amma A1 and then B1 ki right enti B6. Okay, then go for C2. C2 not inserted in root node, always not inserted in root node. Go to the next level after root node. C2 here, yes, correct, available space. Sit down. Yes, a second bench first. Yes, where we can insert C22, where we can insert C22. Yes, C22 here. Okay, but no space, overload. Already overload happened at this node. Overload available, overload happened at this node, means maximum number of elements are already reached. Two element already inserted, third element available here in outside of this range, but not possible. So identify, execute the same process. This one belongs to middle element to the left, to the right. Next C2 belongs to moves one level up here. అంతే కదమ్మా next tell me next tell me C2 not available here. Yes, correct, C2 not available in this, C2 not available in this. Next here B6 किधर? Yes, C here. మా మాట్లాడదు, stop talking and insert all those remaining elements up to the last. Try to execute. I think everyone knows the process. D5 very easy to insert. D5 very easy to insert now. But D6 once again a big problem. We need to move to the up level, and once again the upper level will be reached to the overload option, and finally you need to divide into the middle element. Okay, any confusion in this? No. C22 over D5 here. Then D6, not possible. And D5, most left, that's it. Any doubt? No. Must stop talking. Think you already practiced many problems. We'll go for deletion. Now tell me, what are the options just you are identified in binary search tree deletion? How we are identifying the deletion happened in binary search tree? Binary search tree lo rules and regulations ఏంటమ్మా deletion cheyadaniki? If you want to delete one element, so three conditions are available. Now what are those three conditions? You want to delete one element from binary search tree? That node contain how many children? 0 children or 1 children or 2 children. If you are having 1 children, no problem. Okay. If you are having 0 children, no problem. But if you are having 2 children, how to delete? So first delete that root node and apply any one concept from this. What are those? In order predecessor or in order successor. In order predecessor means identify the max element in left subtree, identify the min element in right subtree. In order successor. Okay, in order predecessor and in order successor. So these are the three reasons we are having to delete one element from the binary search tree. Same we are applying in AVL tree also, but before deleting we are calculating balance factor. But here any balance factor? No, we are having node exceeding range available. Means if you are having more than one element in your node exceeds that element, we need to identify the middle element, and we need to identify that middle element moves one level up and identify the left side element and right side element. So these are the reasons are available in B tree. Then we'll go for deletion here. I will give the deletion part. Okay. I want to draw one tree here. The last problem here I'm giving to draw B tree. Last problem here I'm giving to draw B tree. This is the last problem to create a B tree. This is the last problem to create. Now, try to draw many problems using your own examples. Try to draw B tree. Many elements now here I'm giving. Try to utilize 10 to 15 minutes. Okay. Then I'll go for deletion. 4, 5, 6. Okay. 4, 5, 6, 10. 4, 5, 6, 10, 14. This is the last problem to create a B tree. Now here I am giving many numbers. 4, 5, 6, 10, 14. మాట్లాడద్దు numbers miss అవుతాయి. 4, 5, 6, 10, 14, 15, 16. Then after 16, 20. Then after 16, 20, 23. 27, 14, 15, 16, 20, 23, 27, 50, 50, 50, 51, 52. This is the previous problem available in your final exam. Okay, this is your previous regular exam paper B3 question. 50, 51, 52, 50, 51, 52, 60, 64, 66, 50, 51, 52, 60, 64, 66, 68, 70, 70, 72, 73, 70, 64, 66, 68, 70, 72, 73, 75, 77, 78, 70 తర్వాత ఏంటమ్మా 70 తర్వాత 70 తర్వాత 72, 73, 75, 77, 78, 79, 79 తర్వాత 81, 82, 89, 81, 82, 89. Only few numbers left. 90, 92, 93, 95. 90, 89 తర్వాత 90, 92, 93, 95, 90, 92, 93, 95, 100, 100, 110, 111. Last number 110, 111. 100 తర్వాత 110, 111 అమ్మ. 100 తర్వాత 110, 111. Now try to draw. Make it fast. This is your previous problem. You want which order? In this problem, order given here 5. Order 5. Stop talking. Try to draw in step-by-step fashion. No need to write an explanation for you drawing a binary tree, also called B tree. No need to write an explanation, but in final exam, try to write an explanation with one single statement. When you are pulling one middle element, okay, when you are pulling the middle element, compulsory explain with an example. So in that case, you are identifying the overload case. When you are identifying the overload case, compulsory find out the middle element, pull the middle element one level up, identify the left side and right side elements. Matlad last మాట్లాడదాం. Enough. ఇంకొక 1 hour ఉంది కదా, పొద్దున్న నుండి వచ్చినారు పాపం. I think from a morning, I think up to 4:30. Up to 4, only I think up to 4:30 na. Last, I think in the last session, I think I taken the class up to 4:30. 4 only. For all the classes, up to 4. I think lunch hour different available. Okay, lunch hour. Few of the members available up to 12, up to 12, 12:30, 12:45 like that. Okay, make it fast. All of you just don't discuss. Discuss with zero volume in your bench only. Discuss with zero volume in your bench. This is the previous problem given in your final exam. ఇది ఒక్క పెద్ద ప్రాబ్లం ఇచ్చాడమ్మా. ఇంత పెద్ద ప్రాబ్లం ఎప్పుడు ఇవ్వడు. ఎన్ని నంబర్స్ ఉన్నాయమ్మా టోటల్గా? 34 నెంబర్స్ ఉన్నాయా? అంత పెద్ద ప్రాబ్లం ఏమి ఇవ్వడు. మాక్సిమం 20 వరకు ఇస్తాడు. మాక్సిమం 10 or 20 ఇస్తాడు అంతే. దిస్ ఈస్ ద లార్జెస్ట్ ప్రాబ్లం గివెన్ వన్ టైమ్ ఇన్ యువర్ ఫైనల్ ఎగ్జామ్ ఇన్ రెగ్యులర్. ఓకే, రెగ్యులర్లో ఒకసారి ఇచ్చాడు. ఇంత పెద్ద ప్రాబ్లం ప్రాక్టీస్ చేశారంటే మ్యాక్సిమం మీకు ఇక వచ్చినట్టే. ఒక్క లెవెల్ పైకి వెళ్తూ ఉంటుంది అప్. Just don't discuss. Draw this B tree. If you draw this B tree, finally, you're identifying the all the rules and regulations of B tree. Okay. Remember only 3 rules and regulations. First, find out the order M value, then key value. Try to draw the template node in your B tree. Template node means how many key values we can accept. Maximum number of key values we can accept. Maximum number of key values we can accept. If you stop talking and try to draw within your bench, make a valid discussions, okay? Must stop talking. I'll give 5 to 10 more minutes. Then I'll go for heap tree definition and min and max. Tomorrow I'll go for the operations of deletion, heap tree, then I'll close the complete trees. Okay. Then the last concept, drafts available in ADS. Then the next level, algorithms starts on divide and conquer. Divide and conquer nundi that belongs to algorithm concepts. What is the subject name? Advanced data structures and algorithm analysis na up to heap tree, min and max heap applications that belongs to available in ADS. In next level starts from divide and conquer in your second unit, available in algorithm analysis. This is the last concept in your ADS, advanced data structure. I'll go for the definition and a few very important points about heap in this class. Then I'll go for complete deletion operation and heap tree of your creation, insertion, and deletion of all the examples. Okay. So complete that problem, all of you. Okay. Complete that problem, all of you, and try to execute your creation, insertion, and deletion operation. Okay. So in heap, actually, till now we are discussed here. Till now we are discussed BSD, B trees. Till now we have discussed binary search tree, AVL tree, B tree, and the last tree, which one? Heap. Now, what is B tree? This is also called generalized version of your, this is called generalized version of your B tree. Yes, correct? This is the generalized version of B tree, but we are having other rules available in that. What are the other rules in B tree? What are the other rules? We are having order. Order available in BST. Key value available in BST. Which one available in AVL tree? AVL tree is a binary search tree. AVL tree is also called a binary search tree. But what is AVL tree? It is not complete binary search tree. AVL tree is purely based on one very important invention that is called balance factor. A new invention available in the next updated version in BST, that is B tree. So in B tree, we are calculating in creation and inserting an element. What's that creating and inserting element? We need to calculate order, then followed by key value. So if you are exceeding a key value in your node, so node lemundeyama key values. Those are called values. K1, K2, K3, K4, order 5. Order 5 belongs to up to 4. Order 7 belongs to up to 6. Order 9 up to belongs to 8. I think everyone knows. Overload means maximum number of elements are already inserted in your node. At that time, try to find out the middle element. That middle element moves one level up. Okay, that middle element moves one level up, and left side belongs to the left subtree, right side belongs to right subtree in your B tree. దాంట్లో ఉన్నట్టు కదా బిఎస్టీ లాగా ఏవిఎల్ లాగా లెఫ్ట్ సబ్ ట్రీ ఉంటుంది ఇక్కడ రైట్ సబ్ ట్రీ ఉంటుంది సో వి నీడ్ టు డివైడ్ బేస్డ్ ఆన్ ద మిడిల్ ఎలిమెంట్ వన్ లెవెల్ up not down. Remember always, if you identified overload option, if you identified overload condition available in your node, always we need to identify the middle element. That middle element calculate based on the order. ఇప్పుడు ఆర్డర్ ఎందుకు ఆడ్ నెంబర్ తీసుకుంటున్నామమ్మా డైరెక్ట్గా మిడిల్ ఎలిమెంట్ వస్తుంది ఆర్డర్ 4 తీసుకున్నాను అనుకోండి హౌ మెనీ కీ ఎలిమెంట్స్ అవైలబుల్ ఇన్ ఆర్డర్ 4 3 నా at that time which one belongs to the middle element so already I given the condition that is maximum number of elements we can accept up to m minus 1 that is equal to key value and very important always we can accept only order is equal to which number odd number and one more type of B tree also available that belongs to even number. Okay, even number not available in your syllabus, but order 4 B tree also try to construct. Order 4 B tree also try to construct. ఎలా కన్స్ట్రక్ట్ చేస్తారమ్మా దీంట్లో మిడిల్ ఎలిమెంట్ ఈజీగా ఐడెంటిఫై చేస్తున్నారు సో హౌ టు ఐడెంటిఫై ద మిడిల్ ఎలిమెంట్ ఫర్ ఆర్డర్ 4 ఉన్నప్పుడు 3 ఎలిమెంట్స్ ఉంటాయి సో ఎక్స్ట్రా ఎలిమెంట్ 4 విచ్ వన్ బిలాంగ్స్ ద మిడిల్ ఎలిమెంట్ m by 2 m by 2 plus 1 m by 2 plus 1 4 లో మిడిల్ ఎలిమెంట్ ఏంటిది థర్డ్ 4 లో మిడిల్ ఎలిమెంట్ 3 ఓకే ఆర్డర్ అనేది ఈవెన్ వచ్చినప్పుడు హౌ టు క్యాలిక్యులేట్ ద మిడిల్ ఎలిమెంట్ సో సీల్ వి నీడ్ టు గివ్ ద సీల్ వాల్యూ m by 2 plus 1 m by 2 plus 1 2.5 అంటే 2 కదా 2 plus 1 అంటే ఎంతమ్మా 3 ఓకే సీల్ చేసేస్తున్నాను డైరెక్ట్గా సీల్ చేసేస్తున్నాను that is very important so tomorrow I'll give the complete deletion operation that is a big concept that's the reason here I'm not giving time not supported to give the complete cases of delete operations tomorrow I'll close the heap tree today I'll start a few very important concept from heap tree then I'll close the deletion operation and insertion operation and deletion operation and applications along with these three trees of B tree, AVL tree and heap tree. So three applications చాలా సార్లు క్వశ్చన్ అడిగాడమ్మా ఏం ట్రీస్ ఉన్నాయమ్మా ఫస్ట్ యూనిట్ లో AVL tree, B tree ఉంది నెక్స్ట్ యూనిట్ లో heap tree ఉంది creation, insertion, deletion and application. So always we need to create a tree, inserting an element into a tree, deleting an element into a tree. Okay. Now I'll go for the new concept here. Tomorrow I'll give the deletion operations. Okay. Then I'll close heap tree and B tree. Only small concept, but this is very important. Time not separate. It takes maximum number of 1 hour 20 minutes to give all the cases. 1.5 hours it takes to give all the deletion operations. But listen carefully. Okay. Now I'll go for heap tree. All of you write heap tree. Heap is a data structure keyword. Heap is also called a data structure keyword. But what is heap tree? A heap is a complete binary tree. All of you write. A heap is a complete binary tree. All of you write. A heap is a complete binary tree. Complete binary tree అంటే మీకు ఆబ్జెక్టివ్ క్వశ్చన్స్ వచ్చినప్పుడు complete binary tree A BST B B tree C AVL tree D none of the above complete binary tree which one that is heap tree okay one more name for this what is that one more name for heap tree it is a complete binary tree and two very important concepts available in this min heap and max heap okay things are already told min heap and what's that max heap but I will give clearly about min heap and max heap with the help of an example already given for AVL and B tree na alaga examples ichana alaga kuda istanu heap tree kannidiki for min heap and max heap but we need to know what is a generalized concept of definition and theory for heap tree I will give then I will close in this session okay then just see here suppose H is a complete binary tree H means what heap tree it will be termed heap tree it is satisfies the following properties all of you write the properties of heap tree for each node n in H ఈ ప్రాపర్టీస్ థియరీ చూస్తే కన్ఫ్యూజ్ అవుతారమ్మా మీరు బీ ట్రీ ప్రాపర్టీస్ చూస్తే కన్ఫ్యూజ్ అయిపోయారు కదా బట్ ఎగ్జాంపుల్తో ఈజీగా అర్థమైపోయింది మీకు విత్ హెల్ప్ ఆఫ్ ఎన్ ఎగ్జాంపుల్ వెరీ ఈజీ టు అండర్స్టాండ్ ద క్రియేషన్ ఆఫ్ అండ్ ఇన్సర్షన్ ఆఫ్ ఎన్ ఎలిమెంట్ in B tree using properties theory no confusion with an help of an example very easy to understand okay with the help of an example very easy to understand min heap and max heap heap ante enti properties ante enti first write the theory for this there are two types of the heap what are those min heap and max heap there are two types of the heap min heap and max heap for each node n in H, the value of n is greater than or equal to the value of each node of the children of n. Or, in other words, n has a value which is greater than or equal to the value of every successor of n. So, using this theory, no chance to understand. ఓకే, థియరీతోనే అసలు అర్థం కాదు, ఎగ్జాంపుల్తోనే అర్థమైపోతుంది. ఓకే, విత్ అన్ హెల్ప్ ఆఫ్ అన్ ఎగ్జాంపుల్ వెరీ ఈజీ టు అండర్స్టాండ్. దెర్ ఆర్ టూ టైప్స్ ఆఫ్ ది హీప్. There are two types of the heap. Can I change the slide? No? I'll have write these two very important lines of the properties of heap. Right? Remember here, generalized version of binary search tree. What is that? Generalized version of binary search tree, B tree. Okay? Generalized version of binary search tree. In which binary search tree we are calculating balance factor? AVL tree. ఇలా గుర్తుంచుకోవాలి, ఆబ్జెక్టివ్ క్వశ్చన్స్ వస్తాయి. ఇన్ విచ్ బైనరీ ట్రీ we are calculating balance factor, AVL tree, and in which binary tree that is equal to complete binary tree, that is heap tree. Binary search tree having the following properties: every root node having left subtree and right subtree. Left subtree values are always less than compared with root node, and right subtree always greater than compared with root node. Left subtree and right subtree, subtree అంటారు. I'll go for definition first. I'll have to write here max heap. Max heap example. Max heap ante enti amma? Max heap tree. Then I'll give min heap tree. Okay, max heap tree. Then I'll go for min heap tree. What is that max heap tree? The value of the parent node should be greater than or equal to either of its children's. Put this very important line in box. Or also called, in other words, the max heap can be defined as for every node L, the value of node L is less than or equal to its parent value except the root node. Mathematically, it can be defined as A of parent of I is greater than or equal to A of I. That is called implementation part, but just remember the first one. The value of the parent node should be greater than or equal to either of its children. Draw an example for this. The value of the parent node should be greater than or equal to either of its children. Either of its children means what? Either of its children means what? Either of its children means what? Sorry, min heap kelte telustundi kavu chuddam. 44, that is parent node, yes, correct? And is greater than compared with 40 and 42. And 40 just parent node compared with either of 35 or 43, greater than either of. Either of means 35 కన్నా greater than కదా, greater than or equal. Or equal. Okay, or equal, greater than or equal. Compulsory ఒక నోడ్ తోని greater than ఉండాలమ్మా, కంపల్సరీ. మినిమం 1, either left or right. కంపల్సరీ బైనరీ ట్రీలో ఎలా ఉంటుందమ్మా? లెఫ్ట్ సైడ్ వాల్యూస్ ఆర్ లెస్ దాన్ కంపేర్డ్ విత్ రూట్ నోడ్ కదా, అండ్ రైట్ సైడ్ వాల్యూస్ ఆర్ గ్రేటర్ దాన్ కంపేర్డ్ విత్ రూట్ నోడ్. ఇక్కడ కాదు, డిఫరెంట్ గా ఉంటుంది. సో వాట్ ఈస్ ద మ్యాక్స్ హీప్? The value of the parent node should be greater than or equal to either of its children. ఏదైనా ఒక్కదాంతోనే గ్రేటర్ దాన్ ఉండాలి కంపల్సరీ. మినీ హీప్ దానికి రివర్స్, అదేంటో చూద్దాం. రెండిటికి ఉన్నాయేం కాదు, రెండిటికి ఉన్నాయేం కాదు. ఓకే, బట్ మినిమం compulsory we need to identify one node is greater than or equal compared with root node, compared with parent node. We need to identify the parent node, and in the next level you are having all the childrens. So in those two childrens, binary having how many childrens? Only two. Binary having only two childrens. Complete binary this one. So in this complete binary, so maximum number of children that can be only two are accepted, either 0 or 1 or 2 accepted. In these two children, at least one children belongs to less than compared with root node. అంటే root node కంపల్సరీ ఒక దాంతో గ్రేటర్ దాన్ ఉండాలి, అంతే కదా. సో 44 కంపేర్డ్ విత్ 40 అండ్ 42 గ్రేటర్ దాన్, రెండింటితో గ్రేటర్ దానే ఉంది, నో ప్రాబ్లం. బట్ 40 is greater than 35 but less than 43. But you are identified one less than element in this. Max కంపల్సరీ ఒకటి మ్యాక్స్ ఉండాలి. 42 అసలు లేవు కదా. This is only the max. This is only the max. The value of the parent node should be less than or equal to either of its children. Reverse, that's it. Reverse. Right? Min heap tree. Min heap tree. Min heap tree. ఇప్పుడు ప్రీ ఎగ్జాంపుల్ బట్టి మీరు చెప్పాలి, ఫైనల్గా కంక్లూడ్ చేయాలి. ఐ గివెన్ ద one point available in that. Parent node belongs to which node? Tell me. Parent node belongs to which node? Tell me. Parent node belongs to which node? I'll have to draw this diagram, then I'll give the conclusion for this. The value of the parent node should be less than or equal to either of its children. ప్రాపర్టీ కరెక్ట్గా చదవాలమ్మా, కరెక్ట్గా వెరీ ఇంపార్టెంట్ పాయింట్ ఐడెంటిఫై చేస్తే ఎక్కడ మనం ఫ్లో చేయం. You are not identifying at least a single error in your implementation part also. Try to identify the correct property from your concept. Start from BST, AVL, B tree and heap tree. Now tell me, in the given this is max heap now. So in this example, which one belongs to the parent node? Which one belongs to the parent node? 44, 40, 42 అన్ని పేరెంట్ నోడా? ఒకటే పేరెంట్ నోడ్ ఉంటుంది, అంతే కదా. టెల్ మీ విచ్ వన్ బిలాంగ్స్ టు ద రూట్ నోడ్, ఆల్సో కాల్ పేరెంట్ నోడ్. రూట్ నోడ్ ఆల్సో కాల్ పేరెంట్ నోడ్. ఇప్పుడు మీకు కరెక్ట్గా చెప్తున్నాను, రూట్ నోడ్ ఆల్సో కాల్ పేరెంట్ నోడ్. ఇప్పుడు కరెక్ట్ పాయింట్ చెప్పండి. ఇప్పుడు పేరెంట్ నోడ్కి లెఫ్ట్ సైడ్ రైట్ సైడ్ వాల్యూస్ ఉన్నాయి కదా, అది కంపల్సరీ ఏంటది? గ్రేటర్ దాన్ ఆర్ ఈక్వల్ టు. జస్ట్ డోంట్ వెరిఫై ఇన్ ద నెక్స్ట్ లెవెల్. ఓకే, జస్ట్ డోంట్ వెరిఫై ఇన్ ద నెక్స్ట్ లెవెల్, ఓన్లీ వెరిఫై ద పేరెంట్ నోడ్. కంపల్సరీ దట్ పేరెంట్ నోడ్ షుడ్ బి గ్రేటర్ దాన్ ఆర్ ఈక్వల్ టు ద ఐదర్ ఆఫ్ ఇట్స్ చిల్డ్రన్. ఓకే, ఐదర్ ఆఫ్ ఇట్స్ చిల్డ్రన్. Now tell me here, this is the parent node. Now what is the parent node here? 11 is less than compared with 15 and 24. Yes, correct? Yes. Now you got a point? Any confusion? I think got a point. A big flaw available in the previous one. Yes, correct? Parent node tell me in this 11 only. Parent node tell me in this 44 only. 44 always compared with these two nodes only. Compulsory greater than ఆర్ ఈక్వల్స్. ఓకే, ఆర్ ఈక్వల్. ఇక్కడ ఒక కొత్త కాన్సెప్ట్ వచ్చింది, ఆర్ ఈక్వల్స్ అంటే డూప్లికేట్స్ ఆర్ అలౌడ్. Duplicates are not allowed in B tree, in AVL tree, in BS tree. Yes, correct? Duplicates are not allowed. Duplicates are not allowed in B tree, AVL tree and BS tree. Now duplicates are allowed greater than or equal to. గ్రేటర్ దాన్ ఆర్ ఈక్వల్ టు అంటే సేమ్ నోడే కదా, ఈక్వల్ టు అంటే సేమ్ నోడే. సో గ్రేటర్ దాన్ అని ఉండొచ్చు, ఇక్కడ 44 కూడా ఉండొచ్చు. ఓకే, ఇక్కడ 44 కూడా ఉండొచ్చు. ఆర్ ఈక్వల్ అన్నాను కదా. సో డూప్లికేట్స్ ఆర్ అలౌడ్. ఎస్ కరెక్ట్. Duplicates are allowed or not in heap tree? Yes. Try to identify those very important points. Now you got a point. Parent node belongs to 44. Is greater than compared with these two children. And in other words, min heap belongs to 11. Available that belongs to parent node. That belongs to. Tell me. Min heap and enti 11 should be less than or equal to either of its two children. ఐదర్ అంటే లెఫ్ట్ సైడ్కి ఒక చిల్డ్రన్ ఉంటుంది, రైట్ సైడ్ ఒక చిల్డ్రన్ ఉంటుంది. బైనరీ కదా ఇది. దానికి కంపల్సరీ లెస్ దాన్ ఉండాలి. మిన్ హీప్లో కంపల్సరీ గ్రేటర్ దాన్ ఉండాలి. దేంట్లో? మ్యాక్స్ హీప్లో. అండ్ వీఆర్ నాట్ హ్యావింగ్ ఎనీ అదర్ పేరెంట్స్ ఇన్ ద నెక్స్ట్ లెవెల్. ఆల్ దోస్ ఆర్ ఇంటర్మీడియట్ నోడ్స్. ఓన్లీ వన్ పేరెంట్ నోడ్, ఓన్లీ వన్ రూట్ అవైలబుల్ ఇన్ ఎవ్రీ బీ ట్రీ, ఇన్ ఎవ్రీ బైనరీ సర్చ్ ట్రీ, ఇన్ ఎవ్రీ హీప్ ట్రీ. బీ ట్రీలో కూడా ఒకటే root node ఉంటుంది కదా, దాంట్లో key values are more than 1 in B tree also. Key values are more than 1. Yes, correct. K1, K2, K3 and so on. The options are available to insert an element into that root node more than 1, but always we are having how many root nodes? Only one root node in BS tree, in AVL tree, in B tree and heap tree. How many types of heap trees? Two types. Heap tree also called complete binary tree. And what are the two types of heap trees? Max heap tree, min heap tree. A parent node should be greater than or equal to either of its two children. A parent node should be less than or equals to either of its two children. Now one very important point you are identified in this, duplicates are allowed. Okay, duplicates are allowed in this. All of you write here. A binary heap is typically represented as array. All of you write this very important point. I'll give an insertion and deletion, but before that, we need to write the structure of heap tree. Draw the structure of heap tree. Okay, structure vaste insertion, deletion anni clear ga cheptanu. Okay, tomorrow I'll close 2-3 very important concept. B tree deletion, heap tree creation, insertion and deletion, and all the application at a time. AVL tree, a small four points are available in B tree application, AVL tree application, a heap tree application. Within 10 minutes, I'll close all those applications. Application means what are the real-time applications where we are using B tree, where we are using AVL tree, where we are using heap tree. That's it. That is called application. Real-time applications where we are using this concept. In which area we are using these data structure concepts. What are the three very important advanced data structure concepts are available? First, AVL tree, B tree and heap tree, followed by graphs are available. That is also called one more non-linear data structure. We are having two graphs, that is BFS and DFS. Breadth first search and depth first search. That's the end of your ADS. Okay, that's the end of your ADS. If possible, I'll give graphs also in the tomorrow session, if possible. Okay. So heap tree example చెప్తే అర్థమవుతాం, కన్ఫ్యూజ్ కాకండి. Just don't confuse with the help of an example available on the screen. When the creation of a B tree and AVL tree and BS tree, I think no confusion now. Now any confusion in creation and insertion of a B tree? No. But deletion, you don't know the cases. I will give all those cases. It requires 1.5 hours to close B tree deletion, and very easy to give min heap and max heap insertion and deletion. And then I'll close the application of all these three concepts: AVL tree, B tree and heap tree. Operations of heap tree, all of you write. The last one, within few minutes I'll close. Within 20 minutes, 15 to 20 minutes I'll close. Okay, 350 or 355. Operations of a heap tree. First theory cheppestanu kada, rep problem cheppestanu iga anni. Rep theory em undadu iga. Okay, then I'll close all the examples in the tomorrow session. Listen carefully. If you miss those examples, we can't understand how to construct heap tree, how to delete an element from B tree. Create వచ్చింది, deletion రాలేదు ఇంకా మీకు కదా. So I want to give many cases of a deletion like AVL tree, but the different cases are available in your AVL tree deletion and B tree deletion and BSC tree deletion. Okay, Maradama last. The major operations required to performed on a heap tree are insertion, deletion, and the last one merging. But merging operation not available in your syllabus. Merging unda amma? Ledu. These are the three very important operations are available in heap tree. Inserting an element into heap tree, deleting an element from a heap tree, and merging two subtrees into one single tree, either max heap or into min heap. Insertion, deletion, and merging. The major operations. How many operations are available according to your syllabus? Only two. What are those? Insertion and deletion. Merging ledu. Inserting an element into heap tree. That is only the case. Insertion of a heap tree. మళ్ళీ ఎగ్జాంపుల్తోని రేపు చెప్తే అప్పుడు మీకు కంక్లూజన్ వస్తుంది. హీప్ ట్రీ అంటే ఏంటో, మ్యాక్స్ హీప్ అంటే ఏంటి, మిన్ హీప్ అంటే ఏంటో రేపు చెప్తే అర్థమవుతుంది. ఓకే, విత్ అన్ ఎగ్జాంపుల్. Insertion of a heap tree. All of you write the theory first. Theory, all of you write. Insertion into a heap tree must maintain both the complete binary structure and the heap order property. I already given the first point available in the screen now. Heap order property. That is the property. What's the property? With the help of creation, with the help of insertion, I will give. Okay, very easy to understand. The property available in heap tree. What's that property? According to max heap, the different property available. According to min heap, one more other property available. I need to divide these two very important properties available in max heap and min heap. Insertion into a heap must maintain both the complete binary tree structure. Complete binary tree and ento kuda cheptanu repu. Okay, what is the difference between complete binary tree or incomplete binary tree? Okay, what is the difference in between complete binary tree and incomplete binary tree? Its value is compared with its parent's value always. If you want to insert an element, if you want to insert a new element, that new element always be compared with parent node. And child value is always satisfied here. Always we need to compare with parent node only. How to insert? Where we need to insert? According to max heap, according to min heap, I will give. Okay. The properties are different for max heap. The properties are different for min heap. Okay, I will give those in the next level, in the last level, in the tomorrow's class. This అంటే దాని స్పెల్లింగ్ రాయద్దు, అక్కడ డబల్ ఐ రాశాడు వాడు పాపం. This will be continuous, means like iteration property. Iteration means what? Iteration means what? Iteration. What are the iterative statements are available in your PPS or in your Java? Iteration means repeat the same procedure by itself many number of times. That is also called loop. Yes, correct? Loop. What are the different loops are available? For loop, while loop, do while. I want to print hello one time. One printf enough. I want to print hello 100 times. It requires 100 printfs. No, just write one condition. While I equal to 1, I is less than or equal to 100. Okay. And in while loop, write one printf and it starts from initial value to 100. It printf hello 100 times. You are given how many printfs? Only one printf. And it printed how many number of times? 100 number of times. That is a specialty. That's a special feature available in your iteration. Okay. Iteration means repeat the same procedure by itself many number of times up to satisfies your condition. I is less than or equal to 100 ante okay. I equal to 101 అయింది అనుకోండి. 101 is less than or equal to 100. 101 is less than or not equal to 100. That is a you are violating the condition. Means at that time you are come out from the loop. అంటే 1 to 100 వరకు ఎగ్జిక్యూట్ చేసి బయటకు వచ్చేస్తుంది ఇక. ఓకే. సో దట్ ఈస్ అ వెరీ ఇంపార్టెంట్. స్టార్ట్ ఫ్రమ్ మిన్ వాల్యూ అండ్ మ్యాక్స్ వాల్యూ. 1 to 100. మిన్ వాల్యూ ఏంటమ్మా 1, మ్యాక్స్ వాల్యూ ఏంటి 100. దట్ ఈస్ కాల్డ్ ఇటరేషన్. సో అల్గారిథంలో కూడా సేమ్ ప్రొసీజర్ బై ఇట్ సెల్ఫ్ మెనీ నెంబర్ ఆఫ్ టైమ్స్, సేమ్ స్టెప్ ఆల్సో వీ నీడ్ టు రిపీట్ ద procedure in many number of times based on our required condition. So how means I will give using one example very easy to understand. You want this? I already given a very big problem now. Try to complete that problem in your home, okay? Try to create final B tree for the given last example. Already given one big example. I think how many elements in the 30 elements? 32 elements are available in that. That example already you got in your final exam. But anta pedda problem maximum రాకపోవచ్చు. You will get maximum 15 to 20 elements. Average 10 elements వస్తాయి. 10 అంటే చిన్న ప్రాబ్లం. ఆర్డర్ 3కి 10 ఎలిమెంట్స్ వస్తాయి. ఆర్డర్ 5కి మాత్రం 20 ఎలిమెంట్స్ వస్తాయి. ఆర్డర్ ఇఫ్ యూ హ్యావింగ్ ఆర్డర్ 3 కంపల్సరీ యూ విల్ గెట్ అప్ టు 10 to 15 ఎలిమెంట్స్. ఇఫ్ యూ విల్ గెట్ ఆర్డర్ 5 యూ విల్ గెట్ అప్ టు 20 to 25. This is only the largest problem you got in your final exam. Okay. వాడేమో చేస్తున్నాడమ్మా. I'll give this example in the next. Okay. I'll give. You can't understand compulsory. I'll give this heap, sort and heap tree. Heap sorting unda amma లేదు కదా. So you are having only heap tree. What is the difference in between B tree and heap tree? Many number of times available in your final exam. What is the difference in between AVL tree versus B tree? Many number of times available in your final exam. Comparison between all these three also available many number of times in your final exam. Okay, try to find out the table. I will give the notes, lecture notes. Okay, difference between BST versus AVL tree, BST versus B tree, AVL tree versus BST, AVL tree versus B tree, heap tree versus B tree, heap tree versus BST. I will give all those differences, many number of differences. And one more time, one time already you got this question here. Compare these three trees. Three trees means AVL tree, B tree and heap tree. Long question వచ్చిందమ్మా. కంపారిజన్ 10 మార్క్స్ వచ్చినప్పుడు కంపల్సరీ టేబుల్ టైప్ లో డ్రా చేసి డెఫినేషన్ ఎగ్జాంపుల్ డ్రా చేయాలి. నో నీడ్ టు రైట్ ఇన్సర్షన్ అండ్ క్రియేషన్ అండ్ డిలీషన్ ఫర్ దట్. Try to give the differences in between all those three trees according to the data structure properties. Try to write the definition of this heap tree, AVL tree and B tree. Okay. I'll go for this deletion the next. Must stop talking. What happened? Must stop talking. And then how to get the next slide? Why not the other slides? Few more slides available in the left. క్లోజ్ చేసి మళ్ళీ ఆన్ చేయండి అదే అదే వచ్చింది ఇక్కడ ఒకటి వస్తుంది అదే రావట్లేదు ఆఫ్ చేస్తావా వచ్చింది వచ్చింది can insert once again already you copied two slides I will explain two more slides removal of okay I'll close within 5 minutes amma just see here tomorrow I'll give with the help of all the cases with an example very easy to understand I'll have you write the title for this removal of from a B tree removal of an element from a B tree this is the last one from your B tree. Okay. What are the different cases available? I will give the theory. Then very easy to understand using an example. Example తో మాత్రమే అర్థమైతే అమ్మ అంతవరకు థియరీ చూస్తే అర్థం కాదు B tree ప్రాపర్టీస్ చూస్తే మన అర్థమైందా బట్ విత్ ద హెల్ప్ ఆఫ్ ఎన్ క్రియేషన్ అండ్ ఇన్సర్షన్ వెరీ ఈజీ టు అండర్స్టాండ్ హౌ ద ట్రీ is created for the given elements using what are the different properties are available. Now removal from a B tree, removal an element from a B tree. Removal an element from a B tree. Inserting an element into a B tree creation of a B tree, removal an element from a B tree, how to delete, how to remove, what are the cases are available, what are the conflicts are available in removal. I'll give in step-by-step fashion using an example, very easy to understand. Okay, but just right here, during insertion, the key always goes into a leaf. Ante kadamma, when you are inserting a new element, when you are inserting an element, you are inserting a new element in a root node. No, you are verifying into the leaf node. Based on left side or greater than. You are not inserting a new node in root node. Always you are verifying in leaf node, available to the left side or to the right side to the root node. Okay, that is very important at the time of insertion. And now, if the key is already in a leaf node, these are the 2 points all of you right. The 2 points all of you right. During insertion, this one, there are 3 possible ways we can do this in deletion. What are the 3 possible ways in deletion? What are the 3 possible ways in deletion? All of you write these 3 possible ways. During the insertion, the key always goes into the leaf node. For deletion, we wish to remove from a leaf. Ante kadamma? You are verifying in insertion from root node. But deletion ekkadi nundi verify from leaf node in reverse direction. In reverse direction, we are verifying. You are verifying from root node to leaf node in insertion, but in deletion, you are verifying from leaf node to root node. In reverse direction, you are verifying. What are the 3 cases? What are the 3 possible ways in deletion? So these are the 3 very important properties are available, but no confusion. I will give with an help of an example. Using an example, very easy to understand. Okay, theory confuse Godama. Theory if you are exercising one problem with an example, very easy to understand. Okay. What's the first one? If the key is already in a leaf node and removing it does not cause that leaf node to have too few keys, then simply remove the key to be deleted. If the key is already in a leaf node, ante case 1 kadamma, case 1 undi kada, case 1 enti very easy to delete the leaf node na. No next level available, no left subtree, no right subtree, directly delete that. That is the first case. Same like BST, same like AVL tree, but we need to calculate balance factor in AVL tree, but we are not calculating in BST. That's it. Okay, that is the first case. Second case, if the key is not in a leaf node, అంటే ఇంటర్మీడియట్ నోడ్ ఉంటుంది, అంటే ఒక లీఫ్ ఉండొచ్చు దానికి, 1 leaf or 2 leaves. 3 cases, same 3 cases. If the key is not in a leaf, then it is guaranteed. What happened? Once again, we need to use predecessor or successor. Will be a leaf. In this case, can we delete the key and promote the predecessor or successor key to the non-leaf? How means? With the help of an example, very easy to understand. Second ఏంటమ్మా, leaf కాదు, పైన ఉంటుంది. Okay, you are in the upper level. That upper level contains more than one children. One children or more than one. No children, no next level means you belongs to the leaf node. If you are having no next level, if you are having no left subtree or right subtree, మాట్లాడదాం. last benches, just don't discuss. Children means what? Leaf node means what? Your node contains 0 left subtree values and 0 right subtree values. Very easy to delete. Directly delete that node. Like BSC, like AVL tree. But AVL tree lo delete చేసిన తర్వాత we need to calculate balance factor. At that any case, if you will get -2 or +2, stop there and try to verify LL or RR or LR or RL rotations in AVL tree. But in this case, what we do, I'll explain in the next level. Over second point. Can you write the third one, last one? Write the third. If one or two lead to a leaf node, write this slide. Theory toni kanpichukovaddamma. I'll give you an example. I'll give with an example. Very easy to understand. Within 2 minutes, I'll close. Within 2 to 5 minutes, I'll close. After giving these 3 points. In the tomorrow session, first I'll start the B tree deletion. Then I'll go for heap tree creation, deletion. Then I'll give application for all these three trees. Application for all these three trees: AVL tree, B tree, and heap tree. Okay. Always just remember here for these three trees: insertion, creation, insertion, deletion, and application. Till now, creation, insertion, and deletion over for AVL tree and B tree. Deletion not completed, and insertion deletion not completed for min int and max heap. So very easy to understand min heap and max heap. Little bit complex, only available for B tree deletion. Okay. I'll have you write these points. The theory for this. What theory అడిగినప్పుడు రాయాల్సిందే అమ్మా. How the removal of a node last benches. This don't discuss. I think I understand. You are listening from morning 9:30 to till now, na? I think everyone in exhausted position, so no problem. So we are closing within few minutes. And tomorrow we'll start with our fresh minds to listen the classes of B tree deletion and heap tree creation and deletion and all the applications. And now what is called in order predecessor, in order successor? Can I repeat again? Stop talking the last. Over this one. I'll give type 1 deletion on the diagram. Then I'll explain with an example in the next class. Very easy to understand. If your node contain leaf node, if your node contain leaf node means directly delete. Directly delete. Okay, man, all of you close your notes and settle down. We'll move forward to the deletion in the next class. Min heap, max heap, and thank you. Thank you for all. Tomorrow we'll meet. Maybe I think in online.